How do we describe where something is? Okay, for your warm-up, you started by describing where you are, your location. Then you described the location of Houston, and then the location of my classroom. After that, I made you work in a group, and you brainstormed. What did you need to describe the position of something? So you wrote on whiteboards, and then we shared out as a class. There were some common themes, so some people were more or less specific, and some people had different reference points, and some people put numbers and some people didn't. So we refreshed our memory and we talked about the SI units for position, which are meters. We then brainstormed types of coordinate systems. So we're all familiar with the X and Y axes that we usually use to graph things. So we can use those in 3 dimensions if we add Z, but we don't need that for this class. People came up with polar coordinates, like you might see on a radar screen. Grid coordinates, like you would get in an atlas or playing Battleship. We also came up with Latin long, which if you plug it into your GPS, sometimes you can get altitude as well. My running app likes to track how high I am, so I get to see when there's a hill. Like I didn't know because I just run it. Next, we had story time. I read Daft Bat, which is a story about how the bat's perspective is flipped from the other animals. And yet, when they looked at it from her point of view, they realized that she was looking at the same things and describing the same things, but just from a different frame of reference. If you'd like to borrow this story, or if you'd like to read the story, or you missed class, please come see me. I do have the book in my classroom. So why did I read that story today when our question is, how do we describe where something is? And in a physics class. So you could take the philosophical spin on it and talk about other people's perspectives, but really, I wanted to talk about how you can describe the same thing in a different frame of reference. So here's a video that also talks about that.
We're used to seeing things from a particular point of view. That is, from a particular frame of reference. And things look different to us under different circumstances. At the moment, things look...
You look peculiar. You're upside down.
No, you're the one that's upside down.
No, you're upside down.
No, I'm not. He's the one that's upside down, isn't he?
Well, let's toss for it.
All right.
Okay. You lose. He's the one that's really upside down. You better come into my frame of reference now.
My frame of reference was inverted from what it usually is. That view of things would be normal for me if I normally walked on my hands.
This represents a frame of reference. Just 3 rods stuck together so that each is at right angles to the other 2. Now I'm going to move in this direction. You see the frame at the same spot on your screen, but you know I'm moving this way because you see the wall moving this way behind me. But how do you know that I'm not standing still and the wall moving? It was the wall that was moving. Now the wall has disappeared, and you have no way of telling whether I am moving or not. But now you know that I'm moving. The point of this is that all motion is relative. In both cases, I was moving relative to the wall, and the wall was moving relative to me.
All motion is relative, but we tend to think of one thing as being fixed and the other thing as being moving. We usually think of the earth as fixed, and walls are usually fixed to the earth, so perhaps you were surprised the first time when it was the wall that was moving and not Dr. Hume. A frame of reference fixed to the earth is the most common frame of reference in which to observe the motion of other things.
This is the frame of reference that you're used to. The frame is fastened to the table. The table is bolted to the floor is anchored in the building, and the building is firmly attached to the earth. Of course, the reason for having 3 rods is the position of any object, such as this ball, can be specified using these 3 reference lines. This reference line points in the direction which we call up, which is a different direction here than it is on the other side of the earth. And these 2 reference lines specify a plane, which we call horizontal or level. In this
Okay, so I stopped the video here because he goes on for a while, but this is all we really need at this point. For an exit ticket, you described Sue's position in reference to her home and to her school based on a figure. I have graded some of these. If they're not in grade speed by the time you see this video, I will return these to you on Monday with some comments on them. You also wrote a reflection in your notebook of what we learned today. Have a great weekend.